The tunnel will be 500 meters below the surface as lava tubes are deeper than this, so it will be able to withstand the pressure and have 350 meters contingency for other parts branching off it. The main elements of the design are here. The dimensions and tunnel design can be seen, as well as the diagram of magnetic levitation, which will be vacuum pumped to reduce friction. The train levitates above a steel rail while electromagnets on the train are orientated towards the rail from below. The system is on C-shaped arms with the upper part of the arm attached to the vehicle and the lower inside edge containing magnets. The rail is situated inside the C between the upper and lower edges. Magnetic attraction varies with distance, so changes in distance between the magnets and rail produce greatly varying forces, so we need a feedback system to maintain a constant distance from the track of 15 mm. Maglev trains are driven by powered guideways. Any two trains on the same route cannot catch up and crash into one another because they are powered to move at the same speed. Further, train derailments that occur because of too quickly cannot happen. The further a maglev train gets from its normal position between the guideway walls, the stronger the magnetic force pushing it into place becomes. Further, they work at all speeds, which eliminates the need for separate low-speed suspension system and can simplify track layout. To start the train and for braking emergencies, we have iron thrusters at the front and back of the train. This can be used to start the train, which would then move freely as there is no air resistance or friction, and then at stops the iron thrusters at the front can apply the thrust in the opposite direction to stop it. As the surface gravity on Mercury is only 38% of Earth, the casks will not have much weight, hence the maglev on all four sides of the train will be able to support the casks for 200 humans. The train will be modular, so carriages can be easily attached and detached depending on the required capacity in order to prevent excess energy being used to propel empty carriages, as the capacity can vary from 3 to 200 people and 1 to 15 casks. The cargo carrier diagram can be seen here to show how the casks will fit in, as well as the interior design for human habitable components for the passenger train with side view, floor plan of seating areas and compartment per person, which clearly shows sufficient room for comfortable journey. The loading and boarding procedure flowcharts can be seen here. Top speed estimate is around 100 km an hour. The arrangement for power supply can be seen here. The maximum power usage is 409.5 kilowatts and minimum is 30 kilowatts. We will transport 189 million meters cubed of quantum gas to Mercury, in which will be pumped as an outer layer around the tunnel, which will act as a cooling layer around the tunnels to cool it below -3 Kelvin, so that the electromagnets work at its highest efficiency and the train can move at top speeds. To choose a destination, a pre-project probe is sent to survey concentrations of other materials and then decide alongside information from current topology diagrams whereabouts both tunnels will be placed on the circumference of Mercury. The system will be two tunnels which run alongside each other at the same depth under the surface. In case of an emergency, AR will direct the train to the nearest station. Distress signals will be automatically sent to nearby control centers. You can see the emergency procedures here. Since speed estimate is 100 km per hour, it will only take us 30 minutes with settlement to travel 500 kilometers.